everyone, welcome back to the tutorial on microcontroller peripherals and interfacing. This is facilitator Swarupa and today we are going to see 8051 architecture. This is the second video. So in the previous video we saw in general about the 8051 microcontroller. So let us see the pin description of the 8051 microcontroller. As you can see here, it is a dual inline package of the 8051 microcontroller. It has got 40 pins. Pin 1 to pin 8 are the port 1 pins. Now most of the pins in the microcontroller are dual function, which means that it can perform more than one or two functions. So port 1 is the general purpose input output pin. Moving to pin number 9, pin 9 is the reset pin. Now similar to other devices where we have the restart or reset button, we have the reset pin in the microcontroller, which is used to reset the microcontroller. When we press the reset button, the values in the registers are initialized to 0 mostly, or it can also be initialized to some predefined value. So now here we can see two different types of circuits of the reset pin. We have the power on reset circuit without any manual control, and the second one is the manual reset option, wherein we can see a push button or called as a reset key. Now the reset key is an active high input. When the reset is set to high, 8051 goes back to the power on state. So in order to reset the 8051, the pin should be held high for at least 2 machine cycles. Now what is a machine cycle? One machine cycle consists of 12 clock cycles. So this reset pin should remain high for at least 2 machine cycles. Now in the first method, in the power on reset, the initial charging of the capacitor makes the reset pin high, and when the capacitor is charged fully, it blocks the DC, and then it again discharges through the capacitor. Now in the manual reset, when we press this reset key, we get a positive voltage across the reset pin and the reset pin is made high. Moving forward, the 10th pin, pin number 10 to pin number 17 consists of the port 3 pins. Now pin number 10, P3.0, also is the RXD pin, and pin number 11 is the TXD pin. Both these pins are used for communication with external devices. Pin number 12 is the input of the interrupt 0, INT 0, and pin number 13 is the input of the interrupt 1. Pin 14, 15 are the inputs of counter 0 clock and counter 1 clock respectively. Whenever the timer of the microcontroller overflows, it can generate an interrupt on these pins. Pin number 16 is used for writing signal to write content on the external ROM, and pin number 17 is for reading signal to read the content of the external ROM. Pin 18 and 19 are connected to the oscillator circuit. We need to connect an external crystal to these two pins. Pin 20 is ground. Pin 21 to 28 is the port. Sometimes it can happen that we write a program in the 8051 and the program is huge and it exceeds the limit of the internal memory of the 8051. So we need to connect an external memory to the 8051. So whenever an external memory is used, these port pins work as higher order address bus. That is, it carries the MSB bit of the address of the external ROM. Therefore, they are named from A8 to A15, that is the MSB. Now pin number 29, PSEN bar. It is the program status enable. It is an active low output pin. So whenever we connect an external ROM, a logic 0 appears on this pin which indicates the microcontroller to read from the external memory. And this pin is connected to the output enable of the external ROM. The next pin, that is pin number 30, is the address latch enable. It is an active high output pin. Now port 0, going back here, port 0 is used to provide both address and data whenever an external memory is connected. So this ALE pin is used for demultiplexing address and data. When 1 appears on this pin, it means that the port 0 provides data. When 1 appears, it's a bit typing mistake here, it should be 0. So when 1 appears on this pin, port 0 provides data, whereas when 0 appears on this pin, it provides the address. Now the next pin is pin number 31. It is the external access. Now some microcontrollers like the 8031 and 8032 do not have any inbuilt ROM. So it becomes necessary for those microcontrollers to connect an external memory, or even for some microcontrollers which have inbuilt ROM, as I told you, sometimes there is a need to connect an external ROM. So this EA pin should be connected to ground to indicate that the code is stored externally. Whereas when we connect it to the VCC pin, it means that the code is stored in the inbuilt ROM and no external ROM is used for the program. Moving forward, pins 32 to 39 constitute the port 0 pins. Now, as you already discussed, port 0 can provide the data as well as address. So they function as the address 0 to address 7, that is the LSB of the address bus, and it can also be configured as data pins from D0 to D7. And the last pin is the VCC, where we need to give a supply to the microcontroller. So this is all about the pin description of 8051. Now there are various companies which manufacture the microcontrollers. You can see some of them: Texas Instruments, Atmel, ST microcontrollers, and you can also search for them. 8051 microcontrollers are available in various prices. The Atmel 8051 microcontroller costs near about rupees 49.5 INR, and it may vary from company to company. So this was all about the 8051 architecture. Thank you.